right. Yesterday we did a lesson in math where we were discovering some things. Does anybody remember what we were discovering yesterday in math? Isabel, what were we discovering?
When we were multiplying, if we would get an even or odd number when we multiplied with two even numbers, two odd numbers, or an even and an odd number.
Okay, so we were figuring out the factors when we took an even factor and multiplied it with an even factor. And what did we discover? What did we get with the product? Skya?
It was still even.
The product was even, wasn't it? What happened when we took an even factor and we multiplied it by an odd factor? Josh B?
It's an even product.
It's an even product. So then what happened when we took an odd factor times an odd factor? What did we get? Matthias?
We got an odd product.
We got an odd product. So some of the vocabulary that we were working on yesterday was the word factor and was the word product. We're going to continue with that today, exploring more with factors and products with an activity that you're going to be doing. Now, yesterday we talked just a little bit about some of the things that we like to see when we're working in math. And so we have a few learning goals of what we're going to be doing. And the first one, like we always do in every math lesson, is we're always trying to persevere through math. And that means that anytime we come to a problem we're not sure about, we're still going to have that can-do attitude in trying to solve the problem. And even when we get frustrated, we might have to think of it in a different way. And if what we were solving, if that didn't work, should you just give up?
No.
No. Tell me what we should do then. Taylor, what should we do?
Persevere.
We should persevere. And what does that word really mean? Elliot, what do you think?
Try to think about it.
Try to think about it. What else? Nick?
Try your hardest.
Try your hardest. What else? Frankie?
Keep trying.
Keep trying. I like that. All three of those. So that's going to be one of our learning goals with our mathematical practices. The other one is once we're done with our task, we're going to come back together and you are going to share your arguments with what your thinking was in math. Now, does that mean we're going to sit here and we're going to duke it out when we argue? No, that's not what it looks like in math. Who knows what it looks like in math when we're actually arguing about something that we're thinking? What does that look like, Amelia?
Like, if me and Kevin were, like, I said, well, I think it's 7, and he thinks it's 8. I'm like, it's 7 because this, and then he goes, it's 8 because of this.
All right, so he's explaining it, and is he showing you some math in his thinking?
Mm-hmm.
And are you showing him some math in your thinking? Excellent. So those are going to be two of our learning goals with mathematical practices that I'm going to put up here. And then we have two other big goals of what I'm looking for when you are working on your math today. The first one is I'm going to be looking for students that are using drawings, possibly equations, or even math tools to help you when you're solving those math problems when you're trying to find equal groups. And this isn't anything new. We've been working with equal groups for a while, but we haven't talked about it in probably a month or so. So we're coming back to it and really starting to rediscover and connect some of those learnings and discoveries that we had earlier in the school year and putting them to use now. And our next goal is to possibly use some math vocabulary as we're explaining our thinking. And I've already went ahead and put up the two math terms that we had from yesterday, but there's empty space here. So as we go through the lesson, if we feel that there's some other math vocabulary that we would like to add, or we think we should add based on our conversations, do you think we should add it here?
Yeah.
And I'm going to give you permission. Sometimes if you do come up with a word, I might say, oh, go put that on the board. So this is the spot where you would put that. All right, are you guys ready for your task?
Yeah.
Awesome. All right, we are going to be working on this. Our task says, a teacher wants to place her 36 students into groups with an equal number in each group, how many different ways can the teacher group the students? Now, I'm going to come around and I'm going to give you a sticker that's going to go into your math blue journal. And then it's the same problem that you see up there, and I'm going to let you start to solve it. So if you'll go ahead and get out your blue math journals. I'm sorry? You need to get yours, absolutely. All right, so as I'm coming around with the sticker, I want you to think about the problem and what you're going to do to try to solve it. There you go, Sophia. There you go, Lexi. Okay, if you'll open to your next blank page, Will. Open to your next blank page, please. Nope, I already put it in there. There you go.
I can't find my math
Your blue math journal. It was hiding. Thank you. Here's your sticker. Put that in, please. Sticker. Go next. Thanks. Josh. Thank you. Thank you. Josh. Tara, can you put the ring away, please? I need you to get started on your math. Skaya? Sammy? As I've walked around, I've noticed some of you have put the date in your journal, which I would appreciate if you have not done that yet, if you'd go ahead and put the date so we know when we worked on this problem. Kevin? Isabel? Now, I see people coming behind me. What do you think these students are getting? Cubes. Why are they using cubes? Okay, Sky, why are they using cubes? To help you with a math problem. Do you have to use the cubes? No. Okay, so I want you to think if there's another tool that you could use, that is also available to you. So what are you thinking when you're putting this? What are you going to do, Ulysses?
You can pronounce spoons and eat 2 fingers. If you made 4 groups, it will make 96.
96? Why are we trying to make 96?
I say 6. Yeah,
How much?
they say.
36. Why are you worried about 36?
Because there's
Right. So we're worried about 36 students, and what are we trying to do with those 36 students? put them in what kind of groups? Equal groups. All right, keep going. Okay, I'll be curious to see what you discover.
This is 6 in there. And I found something I look here. And 6 times 6 is 36.
Oh, so you're using another tool. What tool is this?
The multiplication chart.
That's right. And so here you're using, how did you know to put the dots here? How did you start with that thought?
I just put 1 dot on each and 6 times, and I kept adding 1 to each. And then that gave me no more, and then I counted, and they all had a group of 6.
Okay, so where's this 24 number coming from?
Oh, this was just when I went to go get the cubes.
Okay.
When I stopped.
So what's your next step? So now that you found that there can be 6 groups of 6, what's going to be your next thought with an equal group?
I don't know yet.
All right. So you're going to continue with your tool this way, or are you going to use the cubes?
I can't do 3s. I can't do it in groups of 3s.
You can't?
No, I can.
Oh, why don't you try it?
And I need 12 groups.
I'm curious, what are you working on right now?
I took away another set was because that
So how many cubes do you have total?
I have 36
And why are you using 36?
because I have there's 36 students.
Okay, so we're using the number 36 because that's what our teacher is trying to solve. Okay, so what groups are you trying to make right now? Groups of what? Okay, do you think it's going to work?
Yeah.
All right, show me. Let's keep going. Boys and girls, as I'm walking around, be sure that you are drawing those models of what you're discovering in your journal, because when the lesson is over, the math tools will be put away, but we need to know your thinking. So that's why you're using your journal to record your thoughts. It does?
Yeah.
So how many groups of 3 would you have?
12.
All right. So I see that you're drawing some pictures here, but how will you remember what you were thinking here and what you were thinking here? Do you think you want to record down some numbers maybe? Okay, so let's keep going. I'm curious, what are you drawing? Is it easy to draw these when you're trying to make them the same size? Okay, so is there another tool in the classroom that you could use to help you draw those? Possibly. Is there another one that we've used in the past? I know. Well, that's a template. Would the template help you draw those? Okay, I'm thinking of something else. Can I show you? Come on. talk about these. Do I think I know where you're going, Ariel? So tell me about your X's here. What are you working on with these X's on your journal?
Show that 18 times 2 equals 36.
And did you just know that already, or did you use the cubes to help you?
I use the cubes.
I like how you're making a representation there. All right, so now that we found one way, can you find a different way? I think you're coming up with one, aren't you? What are you discovering? So how you let's make sure we're recording that in our journal. Did you know to put 18 in? What were you thinking?
I spent 18 and you spent 18.
How did you know that? What made you think to split them in half? So you're just kind of trying? And then seeing if it works, and if it doesn't work, then you just move on to the next one. All right. So you tried 2, so 2 groups of 18. What other groups have you tried?
Tried groups of 2, groups of 6, and groups of 12.
You think groups of 9 will work? Okay. Keep going. I'm curious, everybody's going with X's now. What is the fascination with X's when we're making our...
You can also do pluses for me.
Yeah, because like doing circles,
It's harder.
So X's are
I just make a
quicker
dot.
to make?
More
Okay.
efficient. I'm making dots.
Okay. Just curious, because I haven't seen you make X's before, but now all of a sudden everybody's making X's. Kind of an interesting process. So what are you thinking with these? How are you coming up with these, Matthias?
My times table.
yeah, like 36 divided by 2.
Would equals 36. So like 3 times 12 is 36.
See, it makes more sense when you're doing equal.
Okay, so you're going more with the equations. Okay, so you're moving beyond kind of doing them with the cubes. Which way do you think is more efficient? Do you think using the cubes is more efficient, or writing equations and using your times table?
Sure, I think that both are really efficient.
Okay. Okay. But you're choosing to use the times table this time, right? Keep going. So Megan, I'm curious, here I see that you're making some X's here. Explain to me how did you know to do 9 here? And then how did you know to put 4 in each one? Okay. And so from this, with the multiplication table, then you're drawing the picture to match this? Is that what you're doing? Okay, and then you're writing an equation that matches what you've drawn? Okay. So in this is all of 36. Okay, and where were you coming up with the number 36? So from our problem. So we're starting with 36 here, right? Okay. And so how did you know to start with 3? And seeing if they could be in groups of 3? Did you just pick a number and start, or? All right, so now that you have this one, what do you think your next problem might be with your equal groups? Well, you have 3 already, so now we have to try something different, don't we? Because in our problem, aren't we looking to see how many different ways the teacher can have equal groups? Okay. So how did you come up with these equations?
So like this one, I put the 6's in there. And after that one, I went down and did the 3 times 12. I got 3 times 12. It's just doubling the number.
What do you mean you're doubling the number? Can you explain that to me?
So the 6, if you have to, 6 plus 6 is 12.
So if we double 6, so you're saying 6 plus 6 equals 12, because that's doubling 6.
And if you were 3, that makes 3.
Okay.
So basically just doubling the 6.
So when you're doing that, you're doubling the 6 to give you 12, and then what does it do with the other factor?
Minus 3.
Would we also be doubling that? Undoubling it, I guess? Or halving it, wouldn't we? Interesting. Would you mind sharing that a little bit with the students? With your thoughts with the halving and doubling? Would you be comfortable with that? Okay, we'll try it, okay. We'll do right now, but probably in about 10 minutes, okay? So tell me a little bit about what you're doing, Sophia.
Can't really figure out another way to do it.
I'm curious, how did you know to put 12 in each group? Oh, I see. So then you just kept evenly dispersing them, and that's what gave you 12 in each group? So, but I'm curious, why do you have a plus sign in between each one where it's saying 12 plus 12 plus 12? What are you doing from up here? I think it has to do with your picture up here. Bless you.
Thank you.
Are these correlated? How are they correlated? Are they the same? Okay, so we pretty much, it looks like you took the 3 groups that you had and you added them together, and when you added them together, what did you get? Okay, all right, and then what are you doing down here? So why are we taking 36 and subtracting 12? Let's go back to our problem. What is our problem asking of us? So an equal number in each group. So if I subtract 36 minus 12, am I looking for equal groups? Okay, so let's keep this where it is, but let's go back to this. So you tried 3 groups of 12. How else could you use these to help you figure out another equal group? I don't know. What other number do you think you could try? Because you tried 3 and you tried 12. What's another number? Okay, so let's try 4. Oh, you did try 4. And so when you were adding the 4s, how much did you get?
36.
So how many 4s did you have to add together to get to 36? So you had to add 9. Okay. So then what does that tell us? How many would be in each? How many groups of 4 would there be to make 36? You just told me. Do you remember? How many groups of 4 do you have to give you 36?
Sure.
Just a minute. Let's count them. Yeah, so 9 groups of 4 give us 36. Okay, so what other number could we try? Looks like you tried one here. Okay, so we've tried 2 and 12. We've tried 9 and 4, and we've tried 6 and 6. Are there any others, or is that it? Pick another number. Let's try another number. Yes, Emily.
I can, instead of 2, multiply into 5.
Okay, go sit down. Oh, yes, write that up there, absolutely. Okay, so what are you coming up with, Ulysses? Okay, all right, so 9 groups of 4. Can we record some of those things down here? All right, so how are you going to draw that when you're going to do 9 groups of 4? What will you do? Okay. Go ahead and draw it. Now, do you think you can draw it on here? Or is there another tool in the classroom that you could use to help you? Can I show you something? Come here, let me show you something that might help you. Do you think we could use this? I think we could. So why don't we draw something on here where we'd have 9 groups of 6 to see if that would help us, okay? Go ahead and sit down and start. All right, so boys and girls, I'm going to have you write down one thought, and we're going to do a check-in right now and see where we are. Okay, each of you are sitting next to somebody, Nick. Each of you are sitting next to someone that is your partner. And what I would like you to do right now is for each of you to take a minute to think about your thinking in solving our problem of equal groups. And as you're having those discussions, what I need to happen is when we do have a conversation, one person has to be talking, and what does the other person have to be doing? Listening. And if the person listening has a question about the mathematics, is that okay to ask?
Yes.
It is. Because I know as I'm walking around and asking some of you to explain, I can't understand what you're thinking with it. So I might ask a question that helps clarify what you're thinking. So it is definitely okay to ask your partner a clarifying question with the mathematics so you can understand it. Because part of our goal is to understand what other people are thinking. Then you're going to switch and let your partner share. And again, if you have questions about that, then you would ask that at this time. Does anyone have any questions on what I'm asking you to do?
No.
All right, so we're gonna take about 4 or 5 minutes, and I would like the person with the longest hair to go first. All right, let's begin. So Sophia, I'm gonna have you and Will share. Who has the longest hair? Sophia does. Okay, so Sophia, can you explain a couple things that you were discovering? And then you need to be a good listener while you're listening. Okay, so Ulysses, what did I just ask you to do? What are you and Mia going to do right now? Right, so Mia, you have the longest hair, so you get to start first. Well, did he hear you? So Ulysses, what did Mia say?
There we go. So I did, this is one group and this is another, or you can do it this way.
Is that something that you did as well?
And I did the division, so I took it for that, and I did groups of 18. 36 divided by 2 equals 18. Then I did groups of 4.
So could you share with her what you're trying to discover right now? So you would say Mia? And what you're doing with your 36?
Plus 16 plus 10 plus 10 plus 10 plus 10 is 36. And then plus 6 is 36. So I did that.
That's 6 times 6.
Okay, so when you put them in groups of 9, how many groups are you going to have, Ulysses? Okay. Does that make sense? You two can keep looking. I need you to start recording on your paper. Okay, and what did he share? What is he doing? He's what? He made an array? For the first one? And then what's he doing with these last? What's he doing with these? Okay, so I'm curious as to why you're adding 5 plus 5 plus 5 plus 5, and then you're adding 10 plus 10 and plus 6.
That's basically the same as this. When you did 5 fives here, we made the 10. All the 10s. And then we added 10, and then I made 16. And then I added 6.
So let's go back to what the question is asking. What are you supposed to be doing?
Show how many different ways
Group the students in what kind of groups? Equal groups. So if I have a 5, 5, 5, are those equal? I've written 10. Are those equal? And 6, are those equal? Okay, so do we need to go back and maybe rethink a little bit with some of this thought? Okay.
She says,
Would you be comfortable if I had you come up and share?
I'm stage 6.
You're stage fright?
Yeah.
So do you think you could go up and help him explain since you listened to how he was explaining?
34.
So you both are going to come up together, okay? Bring your journal with you.
36.
Boys and girls, if I could have your attention in 5,
So he needs to
4,
put that more too.
3,
Because you can.
2, and 1. All right, you've had a minute to share with your partner. What I've asked is for Carson to come up with Colin, and he is going to share, although Colin is going to help Carson speak, because Carson is feeling that he's not sure he can come up and really share. Now, what I noticed when I was going around is this was one way Carson was solving that. So Carson and Colin, I'm gonna let you both go together, and can you explain your thinking with that? Oh, and you know what? We probably need a microphone so everybody can hear you.
Colin's gonna do this.
All right.
He said he did 6.
Okay, Colin, you have to speak up.
It's wrong. It's dead.
Oh, lovely. Okay, can you speak in a loud voice for me?
He said he did 6 times 6 and then went up and then up until it equals 36. He said he did mental math.
So you did mental math. What does that mean, Carson, when you're doing mental math?
Did math in your head.
Okay. But I'm curious, you use tally marks. Can you explain the tally marks to us?
So basically he did 6 groups of 6.
So Carson, you're shaking your head no. Can you explain to us?
I wasn't finished and you
Okay.
Just a whisper again.
He said the tally marks in his head.
All right.
Carson, why don't you say it then?
So
6th grade.
I know, but Carson, you were doing a great job explaining it to me earlier. And you basically, instead of using cubes, you were using tally marks each time you went through, and you were doing it in an equal fashion, weren't you? Okay, thank you very much. Isabel, can you bring yours up and share with us what you are doing in your thinking?
Oopsie, I dropped them.
All right, which one are you going to share with us? Groups of 4. So let's make this a little smaller. I believe that's dead. That makes me really upset. All right. Okay, Isabel, can you explain to us? All right, if everyone can put their attention up to the board, Isabel is going to be explaining her thinking.
So when I was doing it, I just did a bunch of numbers, and I used the cubes to see if it worked. And groups of 4 did, so I did groups of 4. groups of 4 roots. So here's 4, and that makes 8. And so 2, 4, 6, 8, 10, 12, 14, 16, 18, 22, 24, 26, 28, 32, 34, 36.
Okay. So I noticed how you were counting by 2s when you did that. Wait, can you leave those for just a minute? Because the one thing that I noticed is when she did this, she was basically doing circles, and inside the circles, she was then placing the cubes. And how many cubes were going inside the circle?
4.
Okay. Now, it's very similar to what Carson was doing, but instead of using the cubes, he was using what instead? Tally marks. Okay, both great different tools to use. However, adding to this, thank you very much, Isabel. Carly, can you bring yours up? Because I want you to see what Carly was using. Same answer, but just showing it in a different way. We'll just get those in a minute. Isabel. Nope. We're going to use your graph paper. Okay. So I'm going to make it a little bit bigger. Okay, I want you to look at how Carly put hers together with the 4 groups of 9. And Carly, can you explain what you did?
Yeah. I used the cubes, and I decided Mrs. Scherr helped me use something because I wasn't really good at doing boxes all by myself, and I found out that you could do 4 with cubes. And I said or because you could do it a diagonal way. Well, not a diagonal, but going down instead of just going sideways. And that's how come I put or.
All right, any questions for Carly? Clarifying questions. I have one, Carly. What do you mean when you're going sideways? What does that mean?
Well, it means that you're going basically, how can I say this?
Maybe someone in our audience could help. Can you call on someone, Carly, to help explain what you're thinking?
Yeah. It means that you're going this way, like the one at the top is going both ways instead of going up and down, it's going side to side.
Okay, can you come up and point and use those words as you're pointing?
This one's going up and down, this one's going side to side.
Okay, so one is more horizontal and the other one is more vertical?
Yeah.
Okay,
We should go with those words on the board.
we should, shouldn't we? So we're talking about horizontal and vertical. Okay, what is different with what Carly did as opposed to what Carson and Isabel did? Remember, they came up with the same answer. 4 times 9 equals 36. What is different? Frankie?
Instead of using tally marks or dots or cubes, she used arrays.
She used arrays. Should that be a math vocabulary word we put up here? Okay. So Carly used an array. And Carly, I noticed the partner that you sit by, Ariel, also used arrays. Would you raise your hand if you used arrays to help you solve this problem? Okay, thank you. Would you raise your hand if you were using something similar to what Isabel or Carson was using, where you were putting them in groups, but they weren't really making the arrays? Okay. Thank you, Carly. Now, adding on to this, because all of these are different ways we can solve the equal groups. Although Luke Lucas had an interesting thought. So Lucas, can you bring up your journal, please? All right, and what I want us to look at with Lucas, and Lucas, maybe you can speak to this, is we're going to look at his equations. But he had something to say about the equations that I had not thought about yet. So can you share with us and speak really loud?
Well, we have 6 plus 6 is 36. And if you have 6 plus 6, it equals to 12. And then
There was something with doubling. What were you saying with doubling? All right, I'm going to put the equation up here. But he was talking about 6 times 6 equals 36. And then he was, what was the other one? Was it 3 or was it 12?
5 times 12.
Okay, so it was 3 times 12. And I want to have you, as he's speaking, I want you to be thinking about the patterns we talked about yesterday when we were looking at our big number line, when we were putting dots and looking at patterns. Okay, so you were saying something with the 6 and the 12. What was that?
So when you add the 6 and 6, you get the 12.
Brandon, are you listening? Josh, are you listening?
And then subtract the 3 from the 6, you get 3.
Okay, so he was doing something with the 6 and the 12. What do we know about the relationship between the 6 and the 12? Jenna?
When you double the 6, it equals 12.
When we double the 6, it equals 12. So I'm just going to add some words here. So when we double the 6, it gives us 12. All right, and then what about this relationship between the 6 and the 3? What do you notice? Nick?
If you double 3, you get 6.
Okay, so if we double 3, we're going to get 6. It's interesting. Frankie? Nothing? All right. What do you guys think about that?
Really cool. It's really pretty cool.
Why does that work? Because it works, doesn't it?
Yeah.
Kevin, why does that work?
I see a pattern like when you do 3 times 12, to split the 3 12s into 6, and then you get 6 6.
Okay, can you come up and draw it on this chart paper here for me? Because I'm having a hard time following that.
Okay, so you have like
Okay, you have to write a little bigger.
is this okay?
Yeah, that's good.
Let's just do this. So it's like
Okay, you have to turn and face your audience so they can hear you.
this is a 12. Split that into split all the just split the 12s into.
Okay, so take your marker and split them in half. Okay, let's split them in half bigger. Because we want to see what you're talking about. Okay.
And now splits. Now the 12s are into 6, and if we can see.
Okay, so he said now the 12s are into 6s. Do you see how he made that go into 6s?
And then there's 6.
So he took a line and he halved the 12. And what is half of 12?
6.
Okay, and then he took a horizontal line and he split up the two halves. And he split them into equal groups of 3s. You see what he did?
No, it's like.
No, you didn't do that?
No, what I meant was just you split the 3 12s into 6s, so, and then you get 6 6s.
And you get 6 6s.
Yes.
Interesting. Any questions for Kevin? Go ahead and call in some people.
How does that make 36? Because I thought it was 6 times 6 that only makes 36. Because Lucas did it and it's 6 times 6. I never heard of 6 times 3 is 36.
I didn't say 6 times 3 was 36.
Okay, so what did you think? Can you explain?
I said that there were 3 12s, and I split the 3 12s into 6s, and I get 6 6s, which means it is 6 times 6. Yes, Colin?
I looked at it and I saw you could split into 3s too. The 3s are now.
What do you mean you could split into 3s?
Like you can split it into groups of 3s.
Yeah, you can split.
Can you come up and show us?
Yes, I'm saying you
Making all kinds of interesting discoveries.
You split the 12s into 3s.
The 12 is right here. That and it would still be in groups of 30. That would still equal 36.
What do you mean it would still equal 36?
Yes, if you took these groups away, this would still be 6. These would still be 6.
Okay.
And then by last week, so you just split the 6s, the 6 6s are
Into 9 3s? So 9 3s gives me 36?
No, not 9 3s. How many? 12 3s. Yeah.
So 12 3s
And
equals 36.
And 6 double 6 equals 12, which is exactly.
Is everybody following Kevin? Because he's talking really lightly.
Yeah.
Okay? So he's saying what Colin is doing is he split them into groups of 3 to show that there are 3 groups of 12 that equal 36. And then Kevin, what was the last thing you said about 9s? Did you say something about 9s?
No,
You were saying something about 6s. What were you saying about 6s?
Yeah. He split the 6s that I made into 3s.
Okay, so he split the 6s into 3s, which 3 is half of 6, isn't it?
Yes.
Okay, I think you have some other questions. Thank you, Colin.
Yes, Josh?
You can split on into 2s.
How?
Because 36 is an even number, and so is 2. So you can split them into 2s, like 2, 4, 6, 8, 10, 12, 14.
Yes, we did split it into this little line splits it into.
Yeah, I mean you can split like 2 of those x's into just 2, and then split another row of 2, 2, 2.
And so how many 2s are actually in 36 then? Did anybody figure that one out?
18.
18? Are you sure it's 18?
Yeah.
But I think it's interesting. Josh used some words we used yesterday. He said 36 is an even number. And earlier in the year, we talked about if it's an even number, we can always half it, can't we, Tiernan? Okay, you still have some other questions.
Yes, I did something kind of like that on my paper. It was kind of different. So I did this.
Are you okay, Kevin?
Yeah, I don't like the noise. So I kind of did the same thing, except I did 12, 12, and 12. And then I also started to build off of it, and then I did twos.
Okay.
So I did twos, and then I did sixes, and then I started doing equations for them.
Thank you. Any other questions for Kevin?
Yes, Ricky?
It's not really a question, but I did something kind of like that.
Well, hold on just a minute. We're going to continue with questions for Kevin. Any other questions for Kevin? All right. There was one more thing that I wanted to add. Thank you, Kevin. There was one more thing that I wanted to add to this, and it goes back, I totally forgot, because Carson wasn't really wanting to speak, and I understand that, because it does get, you can get nervous coming up here. But when Carson was doing his sixes, I think he was starting it, and I think there was someone else over at this table, and I'm sorry, I can't remember who it was. They started counting by numbers, instead of doing it with groups where they were either putting the cubes inside the group or they were putting tally marks, or if they were doing what Carly was doing with the arrays, or how we were thinking in this, what some students were doing is they were saying, wow, if I counted, I think it was by sixes, wasn't it, Carson, that we were doing? So if I counted by sixes, it would be 6, 12, 18, 24, 30, and then 36. Have you thought about counting by numbers as you go? All right. Thank you, Lucas. I'll bring that back to your desk. So we have a lot to think about now, don't we?
Yeah.
Right, and I'm not sure, did we find all the answers
No.
to how many equal groups we can make with 36?
I found another one.
Okay, you found another way? What do you mean?
Like, I did dots and this one.
Okay, so similar to kind of the tally marks? Okay. All right, I think what we're going to do next as we move forward is we're going to continue exploring equal groups as we go. Let's go back to our vocabulary here. Were we talking about factors?
Yes.
And how about products?
Yeah.
So what numbers became our factors? Can you turn to your neighbor and share with them? What were some of the numbers that were factors? Come back to me in 5, 4, 3, 2, 1.
Oh, yeah, 36.
Okay, I heard a lot of different numbers. I heard 3 and 12. I heard 9 and 4, 6 and 6. What about the product? Was there a lot of product numbers?
No.
What was the product?
36.
36, it stayed constant throughout the whole entire exploration that we had. Were we multiplying?
Yeah. Yes.
Were some of you dividing?
Yes, I was.
Okay, and taking those cubes and dividing them out into equal groups?
I did
All right, we added some things in here. What was interesting to me was you all had different ideas of how to solve this. Did we come up with similar answers? We did. Frankie?
I have something else.
I understand, but our time is up. I'm sorry. When we come back to this tomorrow, we'll take a look and see if we can add on to some other thoughts as we move forward with our arrays. So, were you persevering through your math?
Yes.
Okay. Were you using some type of argument for your reasoning with your math?
Yes.
Okay. And then let's go back. Did you use drawings or equations or math tools?
Yes.
All right. And how about using some math vocabulary? How many of you think that we should still continue to work on this math vocabulary? Because it's still, I agree as well. All right, I'm going to ask you to go ahead and close your math journals. You guys did a great job today.